Homework 4 is on rational exponents. So the first two sections we're converting back and forth between exponential form and radical form. So the top section, they're already given to you in exponential form, and then you have to write them in radical form. So this one, the 1/2 power, remember to convert it into exponential form, that 2, the denominator, becomes the index in the root, and then whatever was here before becomes the power. So like 28 to the first, you don't have to write as an exponent, and technically you don't have to write the 2 as an index, because if you've got the 2 there, it's implied that it's a square root. So this is the square root of 28. The directions state to simplify if needed, so 28 itself is not a perfect square, but it has a factor that is. 28 can be split into 4 and 7, and then the square root of 4 is 2. So this breaks down, once you're all done, to 2 root 7. All right, let's do one of the next set as well. So this one, rewrite the expression in exponential form. So you basically just do the opposite. When you have the nth root of something to the m power, you write it as the m over n exponents. All right, so 10 is our base, and then 3 is the numerator, and then that 4 that was the index is now the denominator for our exponent. All right, so those ones are pretty straightforward, writing them in exponential form. And then our next set, we've got a couple different examples that we can look at here. There's a 3-step process that I had in your notes for simplifying expressions with rational exponents. Step number 1, and this is kind of an if necessary sort of step. Write all radicals in exponential form. Okay, so these ones, with number 11, we're going to start with this one. They're already in exponential form, so you don't have to do step 1 for this one. Number 2, use the exponent rules to simplify the expression. So one of our rules says if we have the same base like this, and then you've got 2 different exponents, you can add those exponents together. So when we add 1/2 and 5/2, we get 6/2, which is the same as 3, and then you can take 9 and raise it to the 3rd power. So that would be 9 times 9 times 9, which would be 81 times 9, and that is 729. All right, I want to do that one. I wanted to do number 20 as well. All right, so this one, when we follow step 1 says write all radicals in exponential form, so I do have to do that in the denominator. So the numerator is just a 16. The denominator I can take, and when I have the 4th root and the 3rd power, the 3 becomes the numerator, the 4 becomes the denominator. So that's step 1. I had a radical, but I rewrote it in exponential form. Step 2, use exponent rules to simplify the expression. So remember, this 16 is technically like 16 to the first. So when you have the same base and then you've got a quotient set up like that, your exponent rule tells you to subtract. All right, so I'm going to subtract 1 minus 3/4, and that will give me my new exponents. So 1 minus 3/4 leaves you with 1/4. And then step 3, write your answer as a radical in simplest form. All right, so a radical would be the 4th root of 16, and that's actually something that's on our list of perfect 4th powers. The 4th root of 16 is 2.